husky sweatshirts for $20 each. At that price point, 300 students will buy one. For every $5 increment in price, 30 less students will want one. What price will yield what's called the maximum profit, and what is this profit? Question's always going to start with defining our variable, and we're only going to have one in this case, which will just be x. And x is always going to be the number of, and then I'm going to put in brackets price change. Just to give you a general idea, and then we're going to customize it specific to this example. So not everyone will be an increase in price. Sometimes it will be a decrease. So it's whatever the price change happens to be in the question. For this one, it's every $5 increase. I'm going to start with P for profit. And generally, how you calculate a profit is you take the number of items that you sold minus the price that you sold each one at. That'll be what's called gross profit, and then in the real world, you would subtract off all of your costs, and that would give you your net profit. Why? We don't need a Y for this one. Why? Right, we don't need a Y. So with this one, we start by setting up two binomials, which is different than all of the other ones. The other ones we started by multiplying and then distributing. Here, we're just going to leave it as two binomials at the beginning. The first number in each binomial is what I call the original values. And what I mean by that is before we make any kind of changes. So at the beginning of this question, how much is what we're selling and how many are going to be sold? 300 are going to be sold, and at what price? $20. Jack, put it away, please. The second number in each binomial, or the back numbers I call them, are after the change. So I'm going to go to the price first because that's what we're changing. What does increment mean? We're increasing. How much are we increasing it by? And how often are we doing that? We don't know. So this is showing the increment of $5. How many number of times is what we don't know. What's happening over here because we increase it by $5? Where does the minus come from? What's the key word in the question? Less 20, and then how many times? X. Make a note your x's will always be in the back. It's 30. Oh, thank you. Make a note that your x's will always be in the back of each binomial. They'll always be the second number in each of the binomial. Questions are always going to work this way. You're going to have the number sold times the price. The original numbers will go in the front. The changes will go in the back, and the x's will always be there. Now we're going to distribute it. We're going to complete the square, and we're going to state the vertex. Don't be afraid of big numbers. This is money. Big numbers are good when we're dealing with money, unless we're paying that amount. But if we're being paid that amount, that's okay. So we're just going to FOIL. So 300 times 20. 300 times 5x. Negative 30 times 20. And negative 30x times 5x. So you might just want to make a note, FOIL. That's how we got to this step. Now I'm just going to rearrange the order so it looks like a parabola. I'm going to put the negative 150x squared first. I'm going to combine the two x's, so I had 1,500 and then minus 600. And then the constant at the back is plus 6,000. Now we're going to complete the square. I've got to factor out the negative 150. It's going to leave me x squared for the first term. Offer of negative 6x. And then that 6,000 I'm just going to push to the end like we always do. Magic number. Offer of plus 9.
No, we have to multiply it by negative 150.
I haven't balanced yet. All I've done is fill in the first one. You're just a step ahead of me.
Oh.
Okay, balance it off.
Plus 1,350.
My binomial squared is going to be? And then the constant at the end.
Plus 1,350.
I want the whole thing.
In my mind, see if I have good mental math abilities.
No, 7,350. What? I can get 7,000. Oh, yeah.
Vertex.
3. 7,000.
The x-coordinate is what you called x, so it's the number of $5 increases. The y value is the max profit. We don't have a variable of y, we have a y-coordinate of the vertex.
You're always going to have a y coordinate. It depends on whether or not you need it.
Now the question asked for two things. What are the two things it asked for? Price and max profit. Well, the max profit is easy because that's just the y-coordinate of the vertex. Don't forget your dollar sign. To find the price, what I'm going to do is just grab this price binomial. So I know that the price is equal to 20 plus 5x. What is x that we just solved for? Bad math says I do the multiplication first, so 5 times 3 plus 20. There's our max price. So it means if we raise the price any more, we're not going to make as much money. If we don't raise it that much, we're not going to make as much money. That's the most amount of money we can make is at this price. Questions? Again, I know the first one, there's a lot going on and the numbers are big. You're going to see it's the same steps every single time for profit questions. Read to read number 2. Don't overthink it. Mm-hmm. Is that enough?
So, what does $35
That is the maximum price that you can sell this sweatshirt for. If you sell it for any more, you won't make as much. If you sell it for less, you won't make as much. So in economics, we call it the ultimum price. It's the best price to make the most amount of money. What's number 8 about? It's about canoes. Keywords. It's a lot of words. We have to start by defining x. X is always going to be whatever the price is changing by. How are we changing the price in this one? So number of $50 increases. Number sold times price, or price times number sold. It doesn't matter the way you put your binomials. The original numbers go in the front. So before we made any changes, how many were sold and what was the price?
$60.
60 canoes. How much money? 500 apiece. The back numbers or the second numbers are always after the changes. How are we changing the price? And how many times are we adding $50? Don't know, so I'm putting an X. Because we do that, what happens here to the number sold? Times X. If you forget your X's, well then you're not going to have a variable, so you're not going to be able to complete the square. If you only put one X, it's not going to be quadratic. It's going to be linear, and you won't be able to complete the square. So you always want to make sure you have your X's in the back. Okay, what next? Nope, it's completely irrelevant to this question. Foil. To throw you off. Good. 60 times 500. 60 times 50x. Negative 4x times 500. Negative 4x times 50x. I was waiting for someone to fix it. So fix that if you didn't catch it the first time. Negative 4x times 50x.
Negative 200x squared.
What next? We just did. Simplify, put it in the right order. What do you want to put first? What would you like to put next? What would you like at the end? Now what? I'm just writing down what you're saying, by the way. So. How do we answer the question? So where do I find that information in all of this mess? X back into where? So grab price because it asks for price. Was it 50? Thank you. Offer of 625. Looking for confirmation? Do you see the similarity between the last one and this one? All right, so same steps every single time. Read the last one. What's it about? Apple trees and an orchard. Let's pick out the key stuff.
The apple trees. 300 apples.
Other keywords?
Lower by 10 feet. How many acres maximal?
Well, this has nothing to do with selling stuff.
It's still the same type of problem.
It is? How does that work?
Well, it's all about production. It's all about production of a certain amount of revenue. It's just this revenue isn't money, it's apples.
I like that.
Apples instead of currency. Come on, you guys are intelligent. I know. You guys definitely. You guys could have easily said it. You know better. You know better than that.
Are we decreasing the apples? Do we have that control? What do we control? And how are we changing the amount of trees?
One tree.
Could you just say let each x equal 1?
But one what?
Do you have to say what it is?
That's what, when you define, you're telling me what x represents. So one tree, one apple, 1 acre, like it's not clear. Okay, we can't have price and number sold, so can we think of something else for this situation? So number of trees,
Number of apples produced.
number of apples. So not only in economics can you use this to figure out how much you should sell something for, you can use it to figure out how much you should produce of a particular item. Okay, before any changes, how many apple trees did we have? And how many apples apiece were they producing? What did we do to the number of trees? We're adding times x. So I'm just going to put the imaginary one so you can see what happened to it. Because we add a tree, what's happening over here? Why? Why would adding a tree mean there's less apples per tree?
Less nutrients in the soil.
Less nutrients in the soil, they're taking sunlight, they're taking water, all these extra things. Okie doke. FOIL, 20 times 300. (20 times negative 10x). X times 300. X times negative 10x. Now what? I'm just writing down what I'm hearing, by the way, so you might want to check this.
Is that a hint?
No, that's not, no, it's not. Not, well, sometimes it is, but not necessarily. It's what she does to make sure we're checking our work.
What are we trying to find?
I'm not sure.
Number of trees, it says. Where can I find numbers of trees in this whole mess?